So welcome to Module 3, which is Research Methods, the scientific method, how psychologists ask and answer questions. And we'll be learning about the scientific method and the different types of research, the different variables involved, problems associated with it, and basically how to answer questions in general throughout psychology. So the scientific method is the process of testing ideas about the world. And we test ideas about the world by setting up situations that test our ideas. And if the data fit our ideas, we're happy with that, right? We support our ideas, and then we can build off of those ideas. And if our data do not fit our ideas, then we must modify our ideas and start the whole process over again. So it can be a fairly complicated series of steps, especially if we don't have data to support our ideas in general. We must rely on making careful, organized observations. So we need quality data to test these ideas and see, does our data fit with our ideas, or do we need to modify and start the process again? And this is a general idea behind the scientific method. Have an idea, test the idea, gather the data. If the data fits, wonderful. If the data doesn't fit, modify the idea and test again. For example, I could have a theory that sleep boosts memory. That pretty much makes a lot of sense if you've ever been sleep deprived for a period of time, and I certainly have. Based on that general idea, that theory, we develop a hypothesis, a more specific testable prediction. For example, when sleep deprived people remember less than the day before, we can actually test that. We can actually measure those things. And so then I gather some data, so I can either give people a regular night's sleep where they're getting enough sleep, or I can give them a shortened night's sleep. But let's say that we can wake them up early after a few hours of sleep versus letting them sleep 8 or so hours. I can then test that idea. I gather that data, I test their memory, and I see if the data support my theory. If the data show that people without sleep can't remember things, well then I'm happy. I supported my theory, and then I can build off of that research. If my data do not support that idea, then I must modify my theory and start the process again. So the various elements that compose the scientific method are theory, hypothesis, operational definition, and replication. Let's start with theory. Theory is an overarching principle based on observation. So it's a general idea, that we can then test later on, hopefully. Some theories are testable within psychology, and other ones are not testable. For instance, psychoanalysis, or the theory of psychoanalysis, is a great idea, but we can't test to see if there is an unconscious. Because how would we determine if there is an unconscious? There's no way to know that. So we can't test that theory, and that's why there's a lot of criticism against psychoanalysis. However, many theories are testable, and this general idea yields to a testable prediction called a hypothesis that follows from the theory. For example, attachment theory talks about the mother-infant bond early in life and how that shapes behavior later in life. For instance, if you have a difficult bond with your mother at 1 year of age, you tend to have a difficult bond in your relationship, or a difficult relationship later in life, or difficult relationships later in life. And that's a theory, and that can be tested. We can examine different attachment styles and the different way they interact with their significant other later in life. Based on our theory, we can form a hypothesis. So I can come up with a very specific testable prediction based on attachment theory. For instance, people that are securely attached, they have a very good bond with their caregiver early in life, are going to have successful relationships later in life. That would be a testable prediction or a hypothesis. And I can gather data from that and then see if I support that idea, and then that can either modify the theory or change the theory. But before we gather data, we need to have an operational definition. An operational definition is a statement of the exact procedures used or operations used in a research study. So if I'm measuring attachment style, because I'm testing this idea about secure attachment styles having better relationships later in life, if I'm measuring attachment style, I need an operational definition of attachment. Operational definition basically is how do you measure something? These are the steps to measure a particular construct or a particular idea. For instance, attachment. I can measure attachment using a self-report measure, like a survey, or I can measure it using some variant of what is called the strain situation, which was a test that was given to infants to measure their attachment at 1 year of age. Maybe I can develop a strain situation for adults and operationally define attachment based on your response in a strain situation that adults enter. It would be difficult, but it's something that could be possibly done. Or I could use some surveys that already are measuring attachment that have been validated and shown to have high reliability and high validity. So there's a wide variety of ways to measure. There's not one perfect way to measure things. Remember, this is psychology. This is not physics, where everyone agrees on what gravity is. This is not chemistry, where everyone agrees on the particular structure of a particular molecule or substance. This is psychology. We all don't agree. We all have different operational definitions. But you need to clearly state the operational definition in your research so that other people, other researchers, can copy or replicate your study if they so choose. So you need to carefully state exactly how you're going to measure the construct or the variable that you want to measure. And finally, we have replication. Replication is when you repeat the research study using the same operational definition, which means you measure things exactly the same way, and you measure it in the exact same steps, same order of steps, but you use different participants. So it's basically the same exact research study, but using different people. And this is important because we want to replicate or repeat the study to make sure that the findings in the study are accurate or valid, what's called valid. That means that they are, they basically hold true to the population of people you're interested in. Sometimes people will perform a research study, get a particular result, a good result, publish it, and then someone else tries to replicate or repeats it and fails to replicate. And this becomes a problem because then we don't know who's right and who's wrong. Ideally, if you conduct a research study and you gather data and you support your hypothesis, you are going to replicate that study. Because the more you replicate, the more confident you are that your results hold to the general population. If you only run the study once and you don't replicate it, you're not so certain, right? So maybe the sample, the group of people you used in your study, are different from the general population. They're not representative of the general population. Maybe you just have a bunch of oddballs in your research study, and they don't represent the true population, the group of people you're interested in studying. That's possible. So you want to replicate so you're more confident that your results hold across different subjects or different participants. And if you replicate 2 or 3 times, you're more confident that your results would hold in the general population that you're interested in studying. Whether that be the college students, elderly people, people with mental illness, etc. Whatever your population of interest is in the study, replication gets you more confident that your results would apply to that population. Sadly, most people don't replicate these days because a replication is generally not publishable. So people skip the replication process, and that leads to some findings that don't hold up, or some controversial findings where people debate who's right and who's wrong, and then labs or researchers are fighting with other researchers, and it becomes a mess. And that's one of the problems in psychology today is failure of replication, or failure of even people trying to replicate. So let's go back to theory. A good theory organizes information, leads to clear prediction or hypotheses, stimulates research, which means people get interested in the theory and they test aspects of the theory, and of course may be replicated. So the more you replicate, an experiment based on, or a research project based on the theory, the more support you lend to the theory. And that's why a theory like psychoanalysis doesn't have much empirical support, because you can't run a study, because you can't measure the unconscious. Well, at least there's not a clear way that everyone would agree on to measure the unconscious. At least I can't even think of a way. So that theory, psychoanalysis, will always be, I'm going to say controversial, but people will always be skeptical, or maybe people don't believe in it because there's no data to support it. Versus a theory that tends to receive a lot of support. Attachment has gotten a good deal of support. The opposite of attachment, which is temperament, has received some support. There's theories of cognitive development like Piaget that's received a lot of attention and research that we'll talk about. So there's many good theories out there that have been studied, but there's still a few theories that are not testable, and those tend to be, I would say, kind of hit or miss with regard to whether people follow those theories. You either have people that believe in it or don't, despite the lack of empirical evidence. So there are several types of research that we'll be discussing in module 3 here. And all of these involve testing hypotheses and supporting or changing / refining theories. We have descriptive research, correlational research, and then we have causation experiments. And causation I'm not going to talk much about because it's a complicated topic, but I'll talk about the superiority of experimental research versus correlational research later in the module. Descriptive research is a systematic, objective observation of people. The goal is to provide clear, accurate pictures of people's behavior, thoughts, and attributes. It's also referred to as qualitative research, and we generally produce a written description of people's behaviors or their thoughts rather than numerical data. Numerical data is referred to as quantitative, and quantitative data is not part of the descriptive research. It's part of survey research and a lot of experimental research. So descriptive research contains several different categories. One is case studies, where we examine an individual in great depth. This provides a lot of ideas. So if we have someone and we interview them for a couple hours, we found out everything about their childhood, their family life, their environment, their likes, their dislikes, anything that could possibly lead to the behavior or the disorder that we're interested in studying. For example, if I'm doing a case study of depression, I could talk to one person about their depression. When did their depression start? How was their family life? Did they have conflict with their parents or their mother in particular, caregiver? Did they have a really stressful life? Did they have traumatic events happen to them at some point in their life? How do they cope with it? What works for them? What doesn't work for them? And then I get a big, huge description. I could have 2 hours worth of interview on depression for this one individual. Well, the good thing is I have a lot of data there, a lot of descriptive ideas and possibilities that could trigger depression and help us understand depression. The negative part is, does that hold to the general population of people that are depressed? Well, probably not. There's a lot of people that are depressed, and everybody's depression is a little bit different. So interviewing one person about their depression is not going to be able to generalize to the entire population of depressed people. So the problem with case study is it doesn't generalize to the entire population. The benefits of case study is if you want to study a very rare disorder, a very rare behavior, then a case study is great because you can't get a lot of people and run an experiment or do a survey with a lot of data points. For example, if I wanted to study the very rare disorder progeria, I would want to do a case study. Progeria is a horrible disorder. It affects young children, and they age 8 times as rapidly as normal. So that means they're dying of old age by 14 or 15 years of age. It's a terrible disease. I mean, they're getting like heart disease at like 10 or 9. They're getting, multi-organ failure at 12 in some cases. You see these kids on TV. It's a very tragic situation. It's a very, very rare event, too. Not many people have progeria. So if you found someone with progeria and you're interested in studying it, of course you're going to do a case study because you're not going to get a group of them. You can't do a survey of a group of people with progeria because they don't exist. There's very few people in the world with progeria. So for a rare event or a rare disorder, rare behavior, a case study is great. Obviously, it's not so great if you have a very common disorder like depression, anxiety, or a common behavior, because then it doesn't generalize to the entire population. Moving on to naturalistic observation, this is when we record behavior in our natural environment. And this doesn't explain behavior, but describes behavior. And we've all engaged in this type of naturalistic behavior research at some point. I call this people watching. So, and many of us have people watched. We sit on a park bench and we watch people interact, and we try to form judgments based on their interactions. Like, what's really going on in the situation? What can I deduce from just observing these people's behavior? We do it on the subway all the time. If you think about the unwritten rules of the subway, one of the unwritten rules of the subway is that, you don't look at people. So you're on the subway and you're looking up at the roof of the subway, you're looking down, you're looking at your book, pretending to read, you're looking at your phone, pretending to surf the internet despite there being no internet connection on the subway. You're doing everything possible to avoid looking at someone because, it's a tragic situation if you make eye contact on the subway. It's, what will people do? I'm just joking, of course. I mean, it's a social norm. People don't look at each other on the subway because it makes people uncomfortable. And you've learned that. It wasn't written. There was no guide or manual how to ride a subway. You learned this rule by riding the subway many, many times throughout your life. And the same thing with above ground trains. There are certain rules to where you sit. You can't sit next to somebody. You have to sit in a particular order of seats. I've ridden the New Jersey Transit train for the last 5 years, pretty much, multiple times a week, coming to work. And it surprises me all the different rules on the train, where you can sit, where you can't sit. If certain seats are filled, you have to stand. If certain seats are not filled, you could sit in certain seats if you're a woman, but if you're not a man, it's very complex. And these are all unwritten rules that I've learned by just watching people walk onto the train and sit down. And one time someone sat directly next to me in a spot that he was not technically allowed to sit according to the unwritten rules of the train. And I just turned and looked at him, and he just got frightened and got up and changed seats. And I think even he realized that he was violating the unwritten rules of the train. I mean, these unwritten rules are technically called social norms. And if you break a social norm, you feel a lot of anxiety. You feel a lot of pressure to adhere to it. And so we've all learned through naturalistic observation at one time or another. And the third type of descriptive research are interviews and surveys. Now, most surveys use numerical data, which is quantitative data, and that would not be considered part of descriptive research. The survey would have to have written responses where you have actually words that you're translating into data. Qualitative survey. An interview, of course, you transcribe the exact words from the interview and use those words to support, test a hypothesis, etc., support a theory. But surveys have problems, in themselves. Surveys tend to ask a lot of personal questions, and people don't like to give personal answers. So if you give a survey on a controversial or an uncomfortable topic, people will answer in a certain way, and that way is a socially desirable way. So they'll answer in a way to put themselves in the best light possible, to make themselves look the best possible, or the way the experimenter wants or the researcher wants them to look. For instance, I once gave a survey on depression, and people didn't give me, honest answers. They gave me socially desirable answers. And basically, they gave me answers to questions like suicidal ideation, where I said, how many times in the past month or the past year have you thought about actually just imagine yourself committing suicide, and they all wrote zero. And we're talking about a bunch of like 18 and 19-year-olds. Several hundred of them all responded zero to this question about suicidal ideation. And I thought to myself, this can't be realistic. All these people have never, thought about suicide in the past year, and they're 18, 19 years old. I hate to seem pessimistic, but I just don't see this as being possible at all. So they were giving socially desirable answers. If you ask people about drugs, how much marijuana have you smoked in the past year or in the past month? They all write zero. And so you look at that and you're like, zero? You're talking about college students not smoking marijuana. Is it realistic to think that all these students are not smoking marijuana? Of course not. Of course we know college students smoke marijuana. So answering zero to a survey on drug usage does not give us the true answer. It gives us a socially desirable answer. They think that's what they want us to know, that they don't smoke. And in reality, they do smoke. It's kind of like a smoker who goes to the doctor and the doctor asks the smoker, how much are you smoking a day? And the smoker says zero. Of course, the smoker is lying. The smoker would be smoking a pack and a half a day. And I actually know someone who actually does this, goes to the doctor, a pack and a half a day smoker, and she goes to the doctor and says she smokes zero. A pack and a half a day smoker saying zero is giving a socially desirable answer. So that's another problem with surveys. Another second problem with surveys is the wording effect, or sometimes people don't understand the language of the survey, so you have to be concerned with that. Or sometimes people they don't remember. You ask them how many times did they have a headache in the past 3 months, and they estimate. And they say, oh, maybe I had like 5 headaches the first month and 6 headaches the second month. They're not 100% sure. They can't remember every single day they had a headache. So they're giving an estimate. And they're not giving a social desirable answer. They're trying to tell you the truth, but they just can't remember. And you see that memory error as also a problem within survey research as well. So let's move on to correlational research. And correlational research is an observation that two traits or attributes are related to each other. Now, correlational research is all about association. So are these two variables, are these two constructs associated, or are they not associated? That means, do they go together or do they not go together? Correlation always deals with data, so therefore, numerical data, I should say. Therefore, it's quantitative research. And the scientific definition of correlation is how closely do two variables or two factors go together, vary together. And we're going to see a variety of examples of variables that go together and don't go together. And which direction do they go together? So there are 3 types of correlation: positive correlation, negative correlation, and a zero correlation. A positive correlation, which goes between 0 and positive 1, that's the range of a positive correlation, indicates a linear relationship where two things either increase together or decrease together. An example of a positive correlation would be the correlation between height and shoe size. So as height increases, shoe size increases. They go together in a positive direction. That's a positive correlation. They both go in the same direction. Now, the closer that correlation is to positive 1, the stronger that positive correlation is. And the closer the correlation is to 0, the weaker the positive correlation is. The negative correlation goes in the opposite directions. So as one variable increases, the other variable decreases. So for example, Facebook usage or Instagram usage and hours studying. So the more time you spend on your Facebook or checking your Instagram or doing your other social media activities, the less time you spend studying for school. So that's a negative correlation. As social media usage increases, time spent studying academics for academically oriented activities decreases. They're going in the opposite direction. So positive correlation, two things go in the same direction. Negative correlation, two things go in opposite directions. And finally, we have a zero correlation, which means that two things are not related at all. So for example, intelligence and shoe size. To my knowledge, there is no relationship at all. So it doesn't matter what your shoe size is. It doesn't mean that people with big shoes are very intelligent or people with small shoes are very intelligent. They have nothing to do with each other. So the correlation is zero. There's no relationship there. A graphical depiction of a correlation is called a scatter plot. And as you can see on the slide, that the range of the correlation goes from 0 to +1 and 0 to -1. If you have a correlation outside of those boundaries, you've made a mistake. Correlation only goes from +1 to -1. The graph on the left, the scatter plot on the left of the screen, is a perfect positive correlation. Now, in real life, you're not going to get this. You're not going to get a correlation of +1, especially in psychology. But you see how those points on the scatter plot go up from left to right. You see how the slope of that line is positive. So for a positive correlation, you're always going to have a positive slope of the best fitting line. The best fitting line is technically called a regression line. But if you draw the best fitting line to the data points and the slope is positive, you have a positive correlation, as you can see on the left of the screen. In the middle of the screen, you see a zero correlation, no relationship between two variables. And the best fitting line here is a horizontal line. So I would draw a horizontal line through these dots. That's the best fitting line. And the slope of the horizontal line is, of course, zero. And that's why you have a zero correlation. And on the right of the screen, you see a negative correlation. You see the dots on the scatter plot are going down from left to right. And if you were to draw the best fitting line or the regression line, it would have a negative slope. And that's how you can tell the difference between positive, zero, and negative correlation. You also have illusory correlation. That's a relationship or a correlation that doesn't really exist. That correlation is caused by some other factor that's involved. For instance, there's a famous example of the correlation between ice cream consumption and rates of crime. There's a positive correlation. So as the ice cream consumption goes up, rates of crime go up. Well, that doesn't make too much sense, right? It's not like people that are engaged in criminal activities tend to have a very sweet tooth and they need to have their ice cream before they go out on like a murderous rampage. That's generally kind of silly, right? And so if you think about the relationship between ice cream and crime, yes, it's a positive correlation, but it's generally caused or accounted for by a third variable, what is called an alternative explanation or a confounding variable. And that alternative explanation is the heat. So when it's very hot out, people tend to eat ice cream. And also when it's very hot out, people tend to commit crimes. I mean, more people are out on the street and therefore more crimes are committed. So it has nothing to do with ice cream causing crime or crime causing ice cream consumption. There is a relationship there, but it's illusory. It's kind of a fake correlation. It doesn't really exist. And that illusory correlation is driven by heat. So when it's hot out, both of those things exist and they kind of artificially go together. And so when you're looking at a correlation, you always want to look for a third variable that can influence the relationship and make that relationship an illusory correlation. You also have regression to the mean, which means that extreme or unusual scores tend to go back towards the average, and regression towards the mean can also alter the strength of the correlation. Sometimes people just perform above their normal value or their expected value or a level of performance, and the next time you test them, they come back towards the average and you get a distorted result. So regression towards the mean can alter the value of a correlation, but you always want to look for the confounding variable or the alternative explanation that's driving the illusory correlation. Always look for alternative explanations. That's the way you become a good scientist. Now, no matter how much the association is, correlation is never causation. Causation means that one variable leads to or causes another variable. You can never have that with correlation, and people make that mistake all the time. They think that one variable causes another. If they're associated, they're associated. But that relationship does not mean that they're linked. They're not causal at all. One variable does not cause another if it's a correlation. The only way to show causality is to conduct an experimental design. Here's the relationship that can occur, which means that two variables that are correlated are not causally related. For instance, if there's a correlation between low self-esteem and depression, that would be a negative correlation, first off, because as self-esteem is going down, depression is going up. So self-esteem and depression are negatively correlated. They're going in opposite directions. Knowing that, self-esteem can cause depression, possibly, or depression could cause drop in self-esteem, or some other alternative explanation, like a stressful event, can cause, or traumatic event, can cause low self-esteem and depression. So whenever you have a correlation, you can have any of these three scenarios. And therefore, we don't know which one causes which, because A could cause B, B could cause A, or some alternative explanation, C, could cause both A and B. And so since we don't know this, we can never say that correlation gives us causal information. There's an advantage to using experimental design compared to correlational design. With experiments, researchers can focus on the possible effects of one or more factors in several ways. So what you're doing here is you're getting rid of the alternative explanations, those confounding variables, like I talked about in terms of the correlation between ice cream and crime. Heat. Heat is an alternative explanation. It's a confounding variable. And by doing an experiment, we're getting rid of that. And we're getting rid of those confounding variables by using a process called random assignment. In random assignment, we assign people randomly to either one of a finite number of conditions in your experiment. Generally, an experiment can have 2 or 3 conditions. It's very rare for an experiment to have more than 3 conditions. And so what we do is we randomly assign participants to conditions. And by randomly assigning participants to conditions, we get rid of the possibility or the possible influence of these alternative explanations or confounding variables. So by randomly assigning people to conditions, we make sure that the only thing that differs between the experimental group and the control group, or the other groups, the treatment group or the control groups, is what we choose to manipulate, the variable that we're actually choosing to manipulate between the groups as the experimenter. And that variable is called the independent variable. So before I proceed further, I just want to give an example of an experiment and how an experiment provides a greater advantage than using a correlation design. So for example, let's say you're a pharmaceutical company and you're studying the effect of a new antidepressant. For this experiment, we can use 2 groups. One group gets the new antidepressant, the other group gets a placebo. A placebo is a sugar pill. Now, the placebo looks and tastes and smells just like the real antidepressant, but the placebo has no effect. It's an inert substance. It's a sugar pill. It's not going to have any effect compared to the antidepressant. Now, we randomly assign people to either get the treatment, the antidepressant, or the sugar pill, the placebo. And by randomly assigning these people to conditions, we are eliminating the confounding variables, the alternative explanations. So if we didn't randomly assign to conditions, what we could happen is maybe everybody that is in the antidepressant group tends to be very smart, and maybe everybody in the placebo group tends to be very, dumb or not so smart, or maybe there's more males in the treatment group and there's more females in the placebo group, or maybe there's more social people in the treatment group and less social people in the control group. But all of these things are alternative explanations. And all of these variables, whether it be gender or socioeconomic status or intelligence or social skills, etc., all these variables are possible confounds. And they blur the effect of the antidepressant compared to the placebo. So maybe it's not the antidepressant, maybe it's the smarter people in the treatment group getting the antidepressant, and there's dumber people in the placebo group, or there's more men or more women, etc., etc. all these alternative explanations prevent us from drawing a conclusion based on the effectiveness of the antidepressant, because they all interfere with that variable being manipulated. Now, that variable being manipulated, the antidepressant versus the placebo, is known as the independent variable. And the variable we're measuring, which in this case would be depression, the outcome of the study, depression, would be the dependent variable. Randomly assigning to people the conditions by, like, say, flipping a coin and saying, you go here and you go in the antidepressant group and this other person goes in the placebo group, by randomly assigning to conditions, we've gotten rid of all the alternative explanations, the confounding variables. And that's kind of how a basic experimental design works, and that's the advantage of random assignment, how it eliminates confounding variables. However, there's a few more procedures we want to do to strengthen the experimental design. And the first one is the double-blind procedure, and this eliminates bias. In the double-blind procedure, the participants receiving the antidepressant or the placebo don't know what they're getting. So remember, the placebo looks and tastes and smells just like the antidepressant. And so you don't know, as a subject or as a participant in the study, you don't know whether you're getting an antidepressant or whether you're getting the placebo. So you are blind to the treatment condition you were receiving. Also, the experimenter giving you the pill, whether the antidepressant or the placebo, doesn't know what they're giving you. They don't know if they're giving you the antidepressant. They don't know if they're giving you the placebo. Generally, that person is a research assistant that works for the experimenter, the principal investigator. And that research assistant is just given the drug or the placebo, and they just hand it to you. They have no idea what they're giving you. So they are also blind. So in that way, it's a double-blind study. The participant, you are blind, and the researcher is also blind to what they're given. The advantage of double blind is it decreases the effect of expectation. So if you thought you were getting the real drug, you might start acting a lot better if you actually thought you were getting the real drug. If you thought you're getting the placebo, you would not change at all. Maybe you'd get even more depressed. So there's an expectation if you know exactly what you're getting. And the same thing with the researcher. If the researcher knows they're giving you the antidepressant, they may interact with you in a way that makes you less depressed. They may say, oh, you're going to feel much better when you take this, right? And that might alter your response to the drug. Or if they knew they're giving you the placebo, they'll say, oh, here, take this, let's cross our fingers, right? So by eliminating the knowledge on both the participant and the researcher, you are eliminating bias in both ways, and that's double blind. Also, a strong study is placebo-controlled. So you always want to give a placebo because there's something called a placebo effect. This is the effect of expectations on the outcome, on the dependent variable, which in this case would be depression. So if you're getting a placebo, you don't know it's a placebo. You think it's the real drug. You might start feeling better, just given the placebo, because you expect to feel better. You expect to get the drug. You expect to get better. You get the placebo, and you're still getting better. However, in most controlled studies, the treatment, the actual antidepressant, must beat the placebo. It must be better than the placebo alone, right, in the majority of trials. Otherwise, the drug doesn't get approved. But the placebo effect is the fact that you will get better even given a placebo because you think you're getting the real deal. You also develop side effects. People that get placebo feel better. They report less depression. If they get placebo for anxiety, they report less anxiety. But they also report side effects. So they say, oh, I got a headache from this, or my stomach hurts, or I feel dizzy. They're getting a placebo. So the fact that they expect to get a real drug, that expectation alone leads to beneficial treatment, right? They show improvement, but they also show side effects, which is kind of crazy, right? They show side effects getting a placebo. But the placebo effect is the effect of expectations. People think they're going to get better, then they will get better, slightly better. You're hoping as a drug manufacturer or someone working for a pharmaceutical company, you're hoping that your antidepressant is vastly superior to the placebo effect. Otherwise, the drug's not getting approved and you just lost a ton of money. So reviewing the variables that I had mentioned previous in the last few slides that are involved in experimentation, you have an independent variable. This is the variable that the researcher manipulates. In the case of the antidepressant study, it's the antidepressant versus the placebo. That's the independent variable. That independent variable has two levels, antidepressant or placebo. You have two groups. But the variable is antidepressant versus placebo. That's controlled or manipulated by the experimenter. Then you have the dependent variable. This is the outcome variable. So in the case of the depression study, obviously the outcome measure is depression. Now, we first need to find an operational definition of depression. So how are we measuring depression? And we can have an operational definition of depression in terms of score on a depression scale. It could be a clinical interview. So a clinician interviews the person and rates their level of depression. It could be some other task you give them that measures depression indirectly. There's a wide variety of different ways. Survey research that measures depression is a very common one. One particular one that I use is called the Beck Depression Inventory, or the BDI. It's a self-report survey that measures depression. It's very convenient. It shows adequate reliability and validity. That means basically it's consistently measures the same thing, and it measures what it's supposed to measure, which is depression. So the outcome measure is always the dependent variable. And finally, the confounding variable is the alternative explanation. So, like I was mentioning, if you don't do random assignment, you can have many alternative explanations. Maybe you have too many men in one group, too many women in another group, or rich people in one group, poor group in another group, poor people in another group, or smart people, not so smart people, social people, whatever. There's a whole variety of different variables that can influence the effect. And the way you eliminate these confounding variables is by using random assignment in your experiment. That balances out the groups, and the groups will only differ on the independent variable if you use random assignment. If you don't use random assignment, the groups can differ on the independent variable and many other alternative explanations or alternative variables called confounding variables. So here's a comparison of the different research methodologies that I introduced. So you should read through this chart and make sure you understand this chart. There are some strengths and weaknesses. Obviously, the strongest design is experimental, but sometimes it's not feasible to conduct an experiment. Sometimes costs too much money. Correlational research is very easy to conduct because you do use surveys for this, and you can collect lots of data in a very short period of time with surveys. You do have the problem with social desirability, but you get a lot of data, and you get the data pretty cheaply. The experiment can be very costly, very time-consuming, and there are certain cases where you can't manipulate people. You can't use random assignment for everything. For example, if you're doing a study on religious preferences, you can't randomly assign people to one religion versus another religion. You can't say, okay, you're Jewish, you're gonna go practice Islam now, and the Christians are going to practice Judaism, etc. You can't do that because this is not realistic. If you do an experiment on the effects of breastfeeding versus bottle feeding, you can't tell one mother you're going to be in the breastfeeding group, and you're going to be in the bottle feeding group, because they're going to tell you, forget it. I'm going to raise the child the way I want to raise the child. I'm not going to do this because you're telling me to do this for experimental wise. So there's some situations that occur that you can't use random assignment, but in a lot of situations you can. And in those situations, experimental design is probably the best way to go. But they all have their values and their advantages and disadvantages, even experimental designs. But if you have a preference, if you have a choice between the three, yeah, experimental design is probably the way to go. So we run these experiments, and we run these experiments in laboratories, but we hope to extract the information from the experiment and predict real life behavior. That's not always the case. Sometimes you find something that works in a lab, but it doesn't work in real life. So there has to be kind of a balance between, what you can get to work in the laboratory and what happens in real life. And running experiments on rats doesn't necessarily predict what's going to happen in human beings, etc. There's always a trade-off, and we hope to design our studies in the laboratory so that they can be the same principles can be generated outside the laboratory, and the same behavior can be observed. But that's not always the case, and there's always a sort of a push and pull between keeping things controlled within the laboratory and keeping things maybe not as controlled outside the laboratory, but it's in a more realistic setting. So, yeah, naturalistic observation is great because it occurs in a natural environment, but you have very little control over what's going on there. An experiment is great because you have control, but it's not in a naturalistic setting. So, can you find a balance between the natural setting and a controlled experimental setting? And it's a tricky situation for most researchers. They hope to try to get what's called the external validity or ecological validity by performing the experiment outside of the laboratory, but it's not always feasible. This slide is basically what I was commenting on previously, that these laboratory environments tend to be fairly controlled and artificial. And do they do they hold to real life situations? The answer is sometimes, and sometimes they don't. But a lot of times you want to start in the laboratory, get things under control, so you don't have all these extraneous influences that you do in real life settings, and then gradually design a study that more closely approximates real life. So start with the artificial lab experiment, and then build your way out to the real life experiment, or as close to a real life experiment that you can generate. Now I move on to a more controversial topic, which is animal research. And, you know, should we use animals in research? The responses vary by culture. In Canada and the US, 60% say medical testing on animals is acceptable. You're saving people's lives, you're developing cures for cancer, for AIDS, etc. You're extending people's life. You're increasing their quality of life by doing research on animals. And animals, if some animals die, it's for the good of human beings. But in Britain, only 37% actually agreed on this, and so there's quite a contrast between people that are in favor of animal research and against animal research. And you see a lot of organizations like PETA, People for the Ethical Treatment of Animals, come out and say there should be no animal research at all. There's too much animal cruelty among researchers. Animals suffer. And having worked with animals myself, I had worked with mice and rats in a behavioral neuroscience lab a long time ago. It's very disturbing to work with animals. It's In some cases you have to sacrifice the animal, which means kill the animal to see if there are changes in their brain, depending on what kind of study you're doing. If you're looking for gene expression, or you're looking for the effects of a particular drug in the brain, you'll actually have to kill the animal. And I knew a graduate student that was doing research on birds and actually had to kill the ring doves that she was working on. And it's a very difficult situation to actually have to kill animals to study psychology. However, if you think about the benefits of uh, animal research has led the way to some really breakthrough treatments, especially in cancer, AIDS, other serious diseases where people's quality of life or the length of their life was considerably worse before the research was carried on in animals. So many people are against animal research, and many people say there's cruelty to animals, and we should do research on humans instead. Well, first thing is, ethically, you can't really do research on humans. You might think it would be beneficial to do research on prisoners, but prisoners are a very protected group, and it's very hard to do research on them. Even if they agree to do research, it's very, very difficult to get permission to do research on them. In terms of animals, you're against animal research until a family member or a loved one's got cancer or dying of a particular disease. And if this animal research saved them, then you're all of a sudden more in favor of animal research because someone close to you is suffering or dying, and you need a cure, and you look towards the laboratory for a cure. And all the cures, all the drugs, everything starts with animal research. Nothing can be done on humans before it's done on animals. And you're going to have some deaths along the way. And unfortunately, you're going to have a lot of dead rats and dead mice. And, yes, people don't care as much about dead mice and dead rats than they would about dead cats and dead dogs. And research would be completely rejected on those animals. But, unfortunately, some of these animals do die. But in the long run, animal research does save a lot of human lives, and you have to consider that. That if you have someone, if you yourself are dying or someone else is dying, um, then there's a trade-off, right? And could you do some research on humans? Maybe not dangerous research or not research that would require you to kill a human being to study changes in their brain. Could you do some research on humans instead of using animals for everything? Yes, and I think there's a lot of superfluous, excessive research done on animals, like in the cosmetic industry. You have some of that, but in general, if animals are used correctly, animals do save people's lives, and there's room for debate, but that is the case. And unfortunately, there's a trade-off, but it happens, and we have to you have to find a place where you can be okay with it and live with it, uh, because there's no way of avoiding all of this animal research. There's government protection for primates, dogs, and cats. So, for example, you're not going to do so much research on dogs, cats, or monkeys. Monkeys are very close to humans, but you can't really do research on them because they're very expensive. But people tend to be very protective of dogs, cats, and other primates, and not so protective of rats and mice. Maybe they just have a negative association with it. So people are more accepting of mice and rats being killed than, say, dogs, cats, birds, rabbits, etc. And all research done today involves something called the Institutional Review Board, or IRB. And the Institutional Review Board actually looks at the experiment you're running and how you're running it, and if it's ethically responsible, if you're not doing excessive harm to animals, if you're doing everything you can to avoid killing an animal or avoid treating an animal in a more aggressive manner. And they will reject any proposal that doesn't take safeguards to protect animals during research. So the IRB is a very important group composed of scientists, lawyers, even lay people in the community that protects the abuse of animals. So you don't see a lot of animals being abused in research. They wouldn't be approved with the Institutional Review Board at their particular university. And Britain has an organization that looks at the social welfare of animals called the British Psychological Society. Obviously, in America, we have the APA, the American Psychological Association, that looks for the humane treatment and the minimization of harm to animals. And even European Parliament has set standards for animal care and housing. So there's a lot of safeguards and a lot of regulations there to protect animals. Could we be doing more? Obviously, you can always do more. I think there's always a reason to revisit this and update this, but there's a lot of protection for animals there, and most animals are being treated humanely as possible. But in some circumstances, the animal has to be sacrificed or killed in order to carry out the research, and that's part of the research with animals that I was very uncomfortable with, and kind of one of the reasons why I went away from researching with animals, doing research with animals. And obviously, there's a few other ethical concerns that are addressed for protecting human beings other than animals. And if you're working with human beings, you have to get informed consent. So you have to actually give a document that details exactly what's going to happen during the research study or the experiment. And that person has to agree to it. They have to basically sign off to say, okay, I agree to participating in this study. These are the risks. These are the potential benefits. These are basically the procedures that are going to happen. So I kind of know what I'm entering into. I'm signing off on an agreement, like a contract, to say that I'm okay with this, and I'm willing to participate in your study. That's called an informed consent. It protects people from harm and discomfort, gives them it talks about confidentiality, like the data will be stored in a secret location that no one will have access to. Your name will not be linked to your data, so no one knows your scores in a particular experimental context. And if you need to deceive people, which in some cases a research study involves deception, which means uh, altering what you're telling the person in the form of consent. You're not telling them the whole story, because if you told them the whole story, that would influence their responses in a way that you don't want to happen. So if you're deceiving someone or using deception, you must fully debrief them, which means explain the extent of the research study afterwards, and that's done in general ways. And deception is relatively rare these days. Not many people are using it too much. But in a deception study, you debrief people, and they're generally okay with it. Very few experiments are causing physical and psychological harm to either animals or to human beings. Most experiments are fairly safe, and they provide a lot of information and a lot of ways to improve treatments and very little harm to the participants in general.